All right, for number 6, we're looking at finding the exact angle in radians, which makes the expression true. And these are the inverse and original functions. And remember, the thing you have to remember about these is that when you have, say, a variable, let's just call it a equal to sine of theta, this is the angle, and the answer to that is a ratio of a triangle. When you have the inverse, the ratio is on the inside of the operation, and it is equal to an angle. So when you have this is mapping from an angle to a ratio. This maps from a ratio back to an angle. So notice this says I'm going to map an angle to a ratio, and then I'm going to map right back to an angle. So how this works is that sine inverse, cosine inverse, and tan inverse, remember, all have restricted domains. The reason for that is so that they become one-to-one functions. So sine inverse of theta, we have learned, or not theta, sorry, of a ratio A, or X, or whatever they want to call it, that has to be defined between quads 1 and quad 4. That's where sine could be positive ratio or negative ratio. And tangent, and of course there is positive and negative sign over here as well, but we want to keep it defined as 1-to-1. So tan inverse of a ratio has to also be defined in quads 1 and 4, because that's somewhere where tangent has positive ratios and tangent has negative ratios. Cosine is a little different, because cosine is, if you do 1 and 4, they're both positive ratios. So we do 1 and 2, where this is cosine is positive over here, but the ratios are negative over here. So this is just how we have to keep in mind when we're working with these problems. So notice 5 pi over 4, you need to locate that actual angle. So 5 pi over 4, it would be in quad 3. That is not going to be in sine inverse's ratio. So notice sine of 5 pi over 4 would give me a ratio. And then I would ask, where is that ratio going to have an angle that fits within this sine inverse domain restriction, essentially? So our question is, first of all, if you're down in quad 3, what sign does sine have? Well, sine is going to be negative down here, because you have negative x's and the hypotenuse is always positive, or excuse me, negative y's and the hypotenuse is always positive. So your opposite would be a negative ratio or negative number, and your hypotenuse is positive. And remember, you always have your saying, all science teachers are crazy. So what we're asking you to really do is to find an angle that has the same reference angle as 5 pi over 4, but is in one of these two quadrants and has the same sign of the sine value. So sine is going to be negative also in quad 4. So what we're really looking for is, what angle would this be if we were in quad 4? Now, it would normally be reported as 7 pi over 4. But when we talk about sine and tangent inverse, we actually go from negative pi over 2 up to pi over 2. So this equivalent negative angle is negative pi over 4. So what we did, so let's just recap, is we realized that this would give me a ratio in some quadrant. So I drew what 5 pi over 4 would look like. Where would that be? I don't even care what the ratio actually is, because we're going to be mapping right back to an angle. Then we said, okay, down here, this is not one of the defined regions for sine inverse. So in this region, sine has a negative ratio. There's going to be a reference angle and a similar negative ratio in another quadrant on one of these two, and the fourth quadrant is a place where sine is negative. So the angle that would match up reference angle-wise would be, and would also meet this condition of negative pi over 2 to pi over 2, is negative pi over 4. All right, so we're going to try a cosine one and also a tangent one before we move on from this. So give me just a second. Okay, so let's do this one of cosine inverse of cosine 7 pi over 4. So for this, first of all, cosine is supposed to be, for the inverse, is going to have to be in quad 1 or 2. So we're going to have to figure out, first of all, where's the angle they gave us? So 7 pi over 4 is down here, almost, it's almost 8 pi over 4, so it's in quad 4. And that would be a pi over 4 or 45-degree reference angle. So And in this quadrant, you do have to know whether or not cosines would be positive or negative, because that's the only way you're going to know which of the two quadrants up here on the inverse should I map to. So in quad 4, cosine thetas are positive values. So that means that we want to map to another place where we have positive cosine value ratios. And out of quad 1 and 2, the place where the x's are positive is in quad 1. So this would be the reference angle that would be the same would just be pi over 4. So that is it. All right, let's look at the tangent one. So this is tan inverse of tan of 5 pi over 6. So let's first of all focus on where that is. 5 pi over 6 is in quad 2, because it's not 6 pi over 6, which is pi. And remember, tan inverse is only defined in quads 1 and 4, and not including the endpoints here. So we need to figure out, first of all, is tangent positive or negative over here in quad 2? And tangents are negative values in this quadrant. And the tangents would also be negative down here in quad 4. This reference angle right here is 30 degrees. This would also be 30 degrees, but we're going to report it so that it stays in the negative pi over 2 to pi over 2 as negative pi over 6. Okay, so you have to locate the quadrant you're in, figure out the actual tangent, cosine, or sine. What would it be ratio? What would the ratio fraction be, positive or negative in that quadrant? And then you have to figure out where would also you have that same ratio for a tangent, cosine, or sine in one of the correct regions for the cosine, sine, or tangent inverse. I know that was a lot of words, but you're really just mapping to the quadrant they give you, and then you're mapping it to the quadrant in the inverse domain that actually has that same ratio sign. And when I say sign there, I mean positive or negative. Okay, so let's look at 7. We've got a couple of these we want to do. So let's find the exact value of this expression right here. So this time, notice the inverse is on the inside, and this is not sine and sine, so we're going to have to draw some pictures. Usually if they don't match, you're going to have to draw the triangles. So this says sine inverse is got a ratio inside of 1/2. Now, for sine to have a positive ratio and be an inverse function, that means we have to be in quad 1. So we're going to go ahead and draw a picture of what that would look like. And then this is opposite over hype, so that would be 1 over 2 for the hype. We can use Pythagorean Theorem, which I already know it's going to be a square root of 3 because this is a 30, 60, 90. But in case it's not, because some of them won't be nice, I can use Pythagorean Theorem to solve for that x. So this would be 4 equals x squared plus 1, 3 equals x squared, so square root of 3 equals x. Now, we have just turned this whole statement now into an angle. We don't even care exactly what that angle is. We know what it is in this scenario, but we don't really care. We want to know what is cosine of that same exact reference angle that we have. So this would be square root of 3 over 2 because it's adjacent over hype. And since we are in quad 1, it is positive. All right, so let's try another one. So let's do sine of cosine inverse of negative square root of 2 over 2. First thing we were going to ask is where would cosine inverse have negative ratios? And that's going to be in quad 2 because cosine inverse is defined in 1 and 2. And this is negative square root of 2 over 2, so cosine is adjacent over hype. I already know this is a 45, 45, 90, so I know this is square root of 2, but you could do Pythagorean Theorem to prove that. And then we want to know if this is my theta, what is sine of that theta? So sine is opposite over hype, so it's square root of 2 over 2. Now when they're nice angles like that, you could just know the answer without drawing the picture. But like I said, they won't always be the 30, 60, 90 or the 45, 45, 90. So let's look at a couple more. Let's look at E, because I think these are good ones to practice. So this one is the tan inverse is inside, and it's a square root of 3 over 3. That means it's a positive ratio for tan, so that's going to be in tan inverse, you only have quads 1 and 4. So we're going to put this one in quad 1 since it's positive. And it's square root of 3 over 3, which is, remember that it's going to be square root of 3 is the opposite and 3 is the adjacent. We need to find the hypotenuse. So this is 3 squared plus the square root of 3 squared equals c squared. That's 9 plus 3 equals c squared, which is 12. That's going to be square root of 12, which is 4 times 3, so that's 2 on the square root of 3. Now I know that's a 30, 60, 90, but I don't even need to know that for this because I just want to know what sine of that theta. And that is a funny looking 30, 60, 90, but notice anytime your hypotenuse and one of your sides both have a square root of 3, it's a 30, 60, 90 where it's not been simplified down to this being a 1 yet. But for us, we just needed this labeled correctly so that we could make the ratio. Sine is opposite over hypotenuse, so that's square root of 3 over 2 square root of 3. So sine of theta equals 1/2 because those square root of 3's will cancel out. And then for the last one on this section, and then I believe, yeah, that's the beginning of the calculator permitted part. So I will stop this as the end of this part. We're looking at this one. This is tan inverse is a -1. Okay, for tan to be -1, remember tangent is opposite over adjacent. So that means opposite and adjacent both were exactly the same. That's really negative square root of 2 over 2 over square root of 2 over 2. So that's what's going on there. So it's a 45-degree angle. We don't really care so much about that because we can just label this as 1 and 1. And it's a negative tangent. So in the inverse function, that has to be down in quad 4. And this is my beta, alpha, whatever you want to call it, theta. And this would be opposite over adjacent. And if I use Pythagorean theorem, I would get square root of 2 for that hypotenuse. So that's where that's going to come from. So then I want cosine of that alpha. So that would be adjacent over hype, which is going to rationalize to square root of 2 over 2. Okay, and let's let this be the end of this part. So we are now going to be on the next portion visiting the part where you are allowed to use your calculator.